Okay, more examples. Starts is case C. And in this case, we have our derivative and we have our integral. And u equals a periodic function. And dv also equals a periodic function. Periodic, like trig function, exponential function, something that just keeps, you take the derivatives, you take the integral, they keep oscillating back and forth, back and forth. Okay, so you're just going to keep taking derivatives in this column, integrals in this column, and when do you stop and go back the other way? You stop when the integral portion is a multiple of the original integrand. That's the function you are integrating. So you gotta know when to stop on these tables. Okay, so we're going to do an example, and ours will be the integral of e to the x times sine x dx. Okay, I'm going to do it two ways. Over here I'm going to use L-I-A-T-E to choose u and dv, and over here I'm going to use L-I-A-E-T because there's some cases where you can switch the last two choices for u. So in this L-I-A-T-E, I'm going to choose u to be, I'm going to say let u equal the trigonometric function sine x, then dv will be equal to e to the x dx. Over here, I'm going to let u equal the exponential function e to the x, and then dv will be equal to sine x dx. We're going to get the same answer. Alright, so back over on the first column, where u is equal to sine x, I'm going to set up my table. Derivative over here, integral over here. My derivative, u equals sine x. Then the derivative of that is cosine x. The derivative of that is negative sine x. For the integral, I have dv is equal to e to the x. Don't bother putting dx. The integral of e to the x is e to the x. The integral of e to the x is simply e to the x. Okay, now why did I stop there? I stopped there because if you come back in this direction at the bottom, you're going to get a multiple of the original integrand. The original integrand was e to the x sine x. This product is e to the x times negative sine x, so it's off by just a multiple number, a number negative 1. So let's see, let's set this guy up so we can finish it up. A plus, a minus, a plus the integral at the bottom. Okay, so there's a table, and that means that our original problem, integral e to the x times sine x dx, is equal to positive sine x times e to the x minus cosine x times e to the x, and then plus the integral of e to the x times negative sine x dx. Okay, simplifying that, we see that we have a negative e to the x sine x on the right and a positive e to the x sine x on the left. So what we're going to do is, this is equal to sine x times e to the x minus cosine x times e to the x. And this guy, he's coming over to the other side. We're using algebra. So now we have two of these guys, integral e to the x sine x dx. Then we divide both sides by 2, and we get the integral e to the x sine x dx, which is exactly what we're trying to find, is equal to 1/2 times, pull out a factor of e to the x, and it leaves parentheses sine x minus cosine x, and throw your plus c at the end. This one's done. Let's see if we get the same answer over here. We have our derivative column. We have our integral column. For the derivative, we have u equals e to the x. For the integral, we have dv equals sine x, but don't bother putting the dx. Okay, the derivative of e to the x is e to the x. The integral of sine x is negative cosine x. Now, if we multiply the two on the bottom together, we don't get the original integrand, so let's continue. Derivative is e to the x. Integral is negative sine x. Now, if we multiply the bottom together, e to the x times negative sine x, we do get a multiple of the original integrand, so we're ready to stop. Let's bring our arrows down. Arrow, across, positive, negative, positive integral. Okay, here's what we're using. Let's do that over here. So our original problem, the integral e to the x times sine x dx is equal to positive e to the x times negative cosine x, and negative e to the x times negative sine x, and then positive integral of negative sine x times e to the x dx. Okay, so you see we have a negative e to the x sine x integral on the right, and we have a positive one on the left, so we'll move it over again. So just like last time, we simplify this as a negative e to the x cosine x. Minus and minus is plus e to the x sine x. But then we bring this guy over to the other side, and we get two of these guys. 2 times the integral of e to the x times sine x dx. Multiply both sides by 1/2. Integral e to the x times sine x dx, which is precisely what we're looking for, is equal to 1/2 times the common factor of e to the x times, let's put the positive term sine x first, minus cosine x second, plus c, and we're done, and the answer is the c as the first.